Hello everyone, my name is Jyotiman Banerjee, a cloud security expert specializing in Microsoft Defender for Cloud and your Azure security. So today I want to share a case study that I believe every Azure security professional needs to hear. It is about a large retail organization in Mumbai, so a multi-environment Azure tenant. Okay, across your 12 subscriptions and 3 Azure tenants, a secure score of 67 percentage, which by most measures looks respectable. Okay, so uh, which is looks respectable, and a hidden attack path that nobody had mapped. Okay, so one that ran from a publicly accessible developer laptop all the way to 3.2 million customers records sitting in production. So six configurations, all related to your medium or low severity. Not one of them on the critical remediation list. Okay. So together a catastrophic bridge waiting to happen. So Microsoft Defender for Cloud attack path analysis found it before any attacker did, and we will show you how exactly we did it. Okay, so let's move to your slide 2. So the environment, four stages and one hidden threat. Okay, let me set the scene first. The organization on a ran a standard multi-environment Azure architecture across your four stages: development, test, staging, and production. Okay, so development have your had your three subscriptions, 47 developer VMs, and public internet access configured for developer convenience. It also had your service principles shared with the test environment, which turned out to be a critical mistake. Test had two subscriptions with automated pipeline and a managed identity shared with staging. Crucially, VNet pairing to staging was configured with no NSG segmentation. All traffic was allowed between the two environments. So staging had three subscriptions with production replica data. It had a storage account also, geo replicating to production, and an over permissioned service principle inherited from the test environment. The production had a four subscriptions, 3.2 million customer records, and full financial transaction data. The team assumed it was completely isolated, but it was not. Now, here are the four numbers that frame this entire story. Secure score was 67 percentage, looked acceptable, but concealed a critical attack path. Okay, six medium and low risk configurations that changed into one catastrophic path. 3.2 million customer records reachable via the chain your exploit, and 23rd total attack paths that eliminated after the remediation problem. Okay, so like the how the attack path and misconfigurations and one catastrophic chain happened. This is the actually basically the heart of the case study, and this is like your is exactly what the makes attack path analysis so powerful. Okay, so if you ran Defender for Cloud standard recommendations review, you would see medium to low severity items spread across your environments, nothing that individually demanded urgent action, nothing on the critical list. run attack path analysis, and we have seen we have found the chain. One is your developer VM in dev with a public IP, RDP port 2389, open, no JIT access, accessible from any internet IP, the entry point rated medium. The attacker your compromise is the your VM and pivots to service principal credential stored directly in the VM. Okay. Now the hope two, shared service principles in dev. So contributor rights on both dev and test subscriptions. Credentials stored unencrypted in Windows environments variables. No key rotation in 14 months, rated medium. The attacker authenticates to the test environment using those capitals. Now, hope 3. Hope 3 is your win it peering from test to staging. No NSG rules. All traffic allowed between peered networks, zero network segmentations, rated low. The attacker moves laterally directly to the staging environment. And then hope 4. Over permissioned managed identity in staging. The staging app service managed identity had storage, blob data contributor rights on the production storage account. Granted 8 months earlier for a one of data migration that was never revoked, rated low. Okay. So the attacker uses that managed identity to access the production your storage account. Now, Hope 5 is your production storage account, contains automated weekly database export files, backup files of the Azure SQL database, public blob access was visible by key-based access, was still available, 3.2 million customer records, rated low. Then Hope 6 is SQL database, your yeah, Hope 6, I think we have already discussed. So full PII financial transactions of SQL database account uh, retained, retained for 90 days, no encryption beyond the storage account default, rated critical but only when changed. Okay. So this six findings, five rated medium to medium or low. None, like not one was anyone's urgent list. So together a complete end-to-end compromise of 3.2 million customers records across four environments with your zero detection at any time. Okay. So now how we found it. The discovery did not come from a penetration test. It did not come from a red team or a threat intelligence feed. It came from a structured three-tool security testing workflow, but entirely within Microsoft Defender for Cloud, available to any organization running Defender CSPM at P2 tier. Okay. Step one was attack path analysis. Okay. So what we did was we enabled Defender CSPM across all 12 subscriptions and run attack path analysis focused on the defined critical assets, the production SQL database, the Cosmos DB transaction store, and the Azure Key Vault. Defender for Cloud Graph best analysis engine mapped every possible route an attacker could take to reach those assets across subscriptions, across environments, and across identity boundaries. The analysis returned 23 attack your paths. The cross environment dev to production chain was the most severe. A six hop path was a blast radius of 3.2 million breakoffs. The remaining 22 was single environment change. Okay. The key decision we made here was we prioritize remediation by blast radius, not by individual finding severity. that even distinction matters your and I mean for the path. Okay. So, step two is Cloud Security Explorer. Okay, the attack path analysis gives you what the engine identifies automatically. Cloud Security Explorer lets you query the underlying security graph directly to find relationships. Okay, the automated engine may not your surface. Okay, so we run five targeted your queries, all service principals with cross subscription access found 14 and 6 having with 6 having no rotation in over 12 months, all managed identities with production storage access, confirm the staging managed identity plus 2 previously unknown, all VNet pairing connections without NSG rules found 4, including the test to a staging connection in the attack path. Okay. So, all internet exposed VMs without JIT access, like around 23 VMs, 23 potential entry points, all this we found, okay, and Cloud Security Explorer. Agentless VM scanning also we did at the step 3, okay. The attack chain entry point was your developer VM with public RDP. We use Defender for cloud agentless scanning. No agent development required to inventory all 23 publicly accessed developed VMs. Okay. So all in this way, we also did the remediation. Okay. Once we had the complete picture, we structured the remediation part also as 4 independent fixes. Okay. So we started remediating it also. So yeah. So all I mean the design principle was simple. No single fix should be the only thing standing between an attacker and the data. Every hop needed its own break. Okay, difference in depth applied in specific chain we had mapped. Okay. So all things slowly been fixed. Okay. The result is the cross environment access to production data. I mean, architecturally, uh, possible. Okay. Now, after the remediation, okay. So results before and after, maybe if we can compare. Okay. So the attack paths to the critical assets from 32 undetected exploitable paths to 0 remaining post remediation, the critical cross environment chain from dev to production, customer records at risk, defender for cloud secure score from 67 percentage to appeared acceptable to 89 percentage that genuinely affects reduced risk. Okay, cross environment service principles from 14 to 9 with 9 having unreviewed cross environment access to 5, all documented, scoped and rotated quarterly. Okay. So the lesson with what we have learned is the final thing. Okay. So yeah, the lesson what we have learned is secure score is not the same as security. Okay, it cannot be like if your secure score is high also, so you cannot say that it is your environment path is I mean it's secure. Okay, the engagement this engagement changed how this team reports security posture to their board permanently. They retired the secure score as the primary board metric. They replaced it with 3 measures like number of active attack paths to critical assets. Very important. maximum blast radius of any single attack path, time to remediate newly discovered attack paths. Okay. So this is a much more honest conversation and a much more useful one. Okay. So, like here is the insight I want you to take away from this video. A secure score tells you how many individual best practices you have implemented. Okay. An attack path tells you what an attacker can actually do with the gaps that remain. They are fundamentally different questions. Most organizations only ask the first one. The second one is the only one that matters to a threat actor. Okay. For CISOs, run Defender for Cloud Attack Path Analysis across your full multi-environment tenant, maybe this week or whenever your project is, about to complete, or before and after also. Every path return represents a route to your critical assets. Okay, the number you get back is more honest than your secure score and more useful to your board. So for cloud architects, treats every VNet peering connection as a security boundary that requires explicit NSG justifications. Environment switch isolation is an architectural decision, not network operation. And for DevOps teams, run Cloud Security Explorer to find all managed identities and service principles with cross-environment access. Any identity touching more than one environment without a documented reviewed justification is an attack chain waiting to be assembled. Okay, please be remember. Okay, so like for closing, what I can say, the 6 weeks after the remediation was complete, Samir, the guy who from a security team of that, retail company, ran a red team exercise scope specifically to test the cross environment chain we had eliminated. The red team spent 3 days trying to replicate the path. They could not get past fix 01. Okay, the JIT VM access blocked their entry point completely. On the fourth day, they found a new path. Okay, a different chain, lower severity, a multi-hop route to a non-critical staging database. Defender for Cloud's attack path analysis had already found it and flagged it for the next remediation cycle. That is what continuous attack path analysis looks like in practice. Not a one-time test, not a quarterly review, a living map of every route into your most critical assets, updated daily, okay, prioritized blast radius and actionable without penetration test. Okay. So my question to close, have you run attack path analysis, access your full Azure tenant? Okay. So you can, like, go for it and then check it. Okay. So maybe you can drop your, attack paths and all details, though it's a security risk, but still maybe you can in some other way you can tell me around. Okay, so I can tell you whether that number is typically for your stage size and what the highest priority path type to address first usually it is. Okay, so thank you for watching this video. It is a very small video. If this was valuable, follow me for more case studies on Microsoft Defender for Cloud, AI, Sentinel, Azure Zero Trust Architecture. Okay. So, Dhrityman Banerjee, now signing off for today, and bye for now.